It's for making VST plugins. Give a short demo about what this looks like. And talk about. Oh yeah. Better?
Yeah, I think it's good. Thank you.
Talk about what the problem is with this API and how it could be restructured. So first, quickly about myself. Yes, so I've been focused on programming languages implementation for most of my career. I'm active in the demo scene. So for those of you who don't know what that is, it's a kind of art subculture that focuses on real-time audiovisual art. So basically you make a program that displays some nice graphics and plays some music. And through this, I've become interested in sound synthesis, which is kind of what brought me into this mess that I'll talk about today. And I've been interested in Rust since about 2014. Used it for a couple of different personal projects. So in my career so far, I worked for ARM on the shader compiler for the first programmable GPU. Worked for QIAGEN on processing DNA sequencing data, and currently I work for Google on translating Dart into WebAssembly. So that's sort of a quick overview. So VST plugins. So this is a plugin standard that was developed by Steinberg. It's a very stripped down version of the trait. There are lots more than this, but this is sort of the representative functions. Like it has things for the host can get some information, initialize the plugin, set the sample rate, switch the plugin between resumed and suspended states. So say now you need to process audio, now you don't need to process audio. And then the processing itself, process events. The host can send various kinds of events to the plugin. Typical events are MIDI events like node on, node off, used when notes are playing in the music. The plugin gets information, say now play this note, and now stop the note again. And then process, which is what inputs and outputs the actual audio. Then there are some parameter mechanisms, so you can define parameters in a plugin. You can change them in the UI. You can also automate them so that they change over time during the music. So the plugin has mechanisms for that. And you could change preset, like change between different sets of parameters. So this is sort of the basic plugin, what it looks like. So I tried this. Let's see if you can hear the sound here. So I tried using this for a plugin. It just uses some sound and and these are the various parameters here. So I can play some sound. I can pull some parameters. So the sound changes based on the parameters. So this particular plugin here is using a technique called the additive synthesis, which is the idea is that you add together a lot of sine waves to generate the sound. So this sound, for instance, here is 400 sine waves added together. And it's a quite heavyweight technique. So it's fine as long as you're just playing a few sounds, but when you have the whole music with this technique, it can get quite heavy on the CPU. So in order to make this better to use, I put in a caching mechanism so that if you play the same note with the same instrument over again, it will just use the cached sound and play it again, so it doesn't have to compute it again. So to play the same sound again is the same sound, so you can just cache it. And then whenever I change a parameter, it will then flush the cache, because then the sound can change, so it has to compute it again. So that's the idea. So I did this with this create, and then when I did this thing here, playing the sound and changing a parameter, then it crashed. So I was wondering why is it crashing? First I thought, oh, it must be crashing in this handwritten assembly code I have in my plugin. So I tried to make a Rust version of that, and it was still crashing. And it also didn't seem like it was crashing in the unsafe code, the bridge code. It was actually crashing inside safe Rust code. It was crashing inside the sound cache, inside some of the data structures there. And they looked like, when I looked at them, they looked like they were completely inconsistent. It looked very weird. So, I mean, generally in Rust, when your Rust code is crashing inside safe code, you can be pretty sure that you have some unsafe code somewhere that is violating the assumptions of the safe code. So the Rust code, the unsafe code is not upholding all the invariants that it must uphold in order for the safe code to work. And of course, I've written whole books about the things that unsafe code needs to do to work properly. One of the most important things is that an exclusive reference must never point to the same memory as any other reference, unless one is a borrower of the other. And what it means that one is a borrower of the other is also something that has written several books about, and they're still being written. But let's just forget that for a bit. So you cannot have like multiple exclusive references or an exclusive and a shared reference pointing to the same thing. So what actually happened here, I found out, is that the DAW is calling the process function to process the audio, and the set parameter function to change the parameter from different threads at the same time. And that violates this particular assumption, right? Because then both of these threads will create a mutable reference to the plugin, because both of these references take self by mutable reference, by exclusive reference. So so this is violated, and you end up having data races and all sorts of weird stuff. So the way the VST plugin standard works is that the DAW has generally two kinds of threads. It has a UI thread, and then it has one or more processing threads, and it will call your processing stuff on the processing thread, and you can call things on the UI thread at the same time. So this is a problem. So first I sort of fixed it by wrapping this cache in a mutex, and then it was no longer crashing. But I mean this is not a solution, right? This is just a sort of a band-aid. I mean, for one thing, it's not the kind of thing you want to have in an audio plugin. You don't want to have locking and all these things. And also in safe Rust, if you're in a situation where you actually need to put a mutex around this, you would normally expect that your code would not compile if you don't do it. So there's something in this setup that is not really how it should be. So that's kind of, well, you could say, we could sort of give up and say, well, we have some host which is some code that we don't control, and it can call our code in any way it likes, and there's nothing we can do about that. it can call it for multiple threads and do all these things. But there is actually, I mean, we can actually help the Rust compiler here. We can tell it like what is being called at the same time, and we can make sure that you never get to the situation where you create mutable references and other references to the same thing. And generally, if you have an object and there are two threads that might call methods on the same object from separate threads at the same time, then both of those methods must take self by shared reference. Otherwise, you would have this duplicate reference problem. So in that sense, given this situation, that what the VST plugin standard is based on is that these things are called from multiple threads at the same time, then the plugin API is fundamentally unsound, right? So if you look at it again, there's the same thing again, and you have this multiple methods that all take self as an exclusive reference, and if multiple of these can be called from the at the same time, then in some sense you could say that the crate is lying to the user about the safety, right? It's not really living up to the safety that it claims. It claims that it's all safe, right? There's no unsafe here anywhere. So I mean, one fix could be to just make all of them take self by shared reference, because then it will all be fine, right? And that is true, but that wouldn't be very practical, especially because then you need to, every time you have some mutation of internal data, you need to wrap this in some kind of thread-safe interior mutability. So you need to use either atomics or some kind of mutex or the locking around these mutable data. And the locking is what we are trying to avoid, right? So we would prefer not to have everything as shared references. But fortunately, there are some. I mean, the host is not calling these methods like arbitrarily. There are some rules that the VST follows, and we can express this by sort of dividing these methods into different categories, right? So, as I said, there's a UI thread and there are processing threads. And some of these initial setup methods, they are only called while the plugin is suspended. So there's nothing else going on at the same time. It's all single-threaded. Then you have the resume and suspend, which switches the state. And when the plugin is resumed, then you're in the situation where you can have processing methods called from the processing thread, and you can have parameter methods called from the UI thread at the same time. So one sort of first idea could be to split it up in a way where you have like you have one object which belongs to the processing thread, and you have one object which belongs to the parameter thread, and then they could just communicate with each other internally, but it will all like work out because there was nothing across the threads. But there's unfortunately that doesn't quite work, because there's some of the methods like the set parameter and change preset which can actually be called from both threads, because the set parameter is used when you tweak the parameter in the UI, and is also used for automation when the parameter is changing throughout the music. And if you have something where the parameter is changed throughout the music and you modify it in the UI or some other parameter in the UI at the same time, the same function could be called from several threads at the same time. So these parameters, set parameter and change preset, they have to take the self by shared reference. So they sort of block this nice idea of just splitting it into two. So So we had a lot of discussion on GitHub about like exactly how to do this, and we sort of came up with like what are the requirements actually? What are the things we want to achieve? Like in order to find a good API design, it is a good thing to first consider what are the goals, right? So definitely a goal is that if you have a plugin which is written in safe Rust, then that never encounters undefined behavior. So the API in itself must be shaped in such a way that you can never get into this situation where you have this multiple references pointing at the same thing. Assuming that the host is well behaved. So this is kind of the key here, that we're not trying to make something that is safe in isolation. Like it's the unsafe code that is responsible for making the safe code safe, right? And the unsafe code in this situation is the bridge code plus all the code in the host that we don't control. But we make some assumptions, right? We assume that the host will follow these VST rules, and under those assumptions, can we make the plugin safe? So that's the goal, right? And we also want the API to be useful for writing a host in Rust. So it shouldn't be too restrictive in the sense that it shouldn't keep the host from calling things from different threads, as long as it's doing that in a way which is according to the VST rules. And it's a bonus if this API can actually to some extent enforce this on the host, so that it's not possible for the host to call it in a way that violates the rules. And we still want the direct Rust to Rust use case also to be possible. So, I mean, we can build some safety feature into the bridges, but we want the safety to not be dependent on this bridge code, because when you do the direct Rust to Rust, there's no bridge code running. So it should be safe in that case as well. And you can, when you split up this, you can do various things. I mean, you can put up some framework that includes some kind of communication or synchronization mechanisms between these different threads. But we also wanted this to be like as little opinionated as possible. We wanted it to be open, so that all the plugins that use this crate could use whatever synchronization mechanisms they want. They could use atomics, or they could use some blocking thing, or they could use whatever, right? So we wanted them still to be free to choose the synchronization mechanism, and in particular, they should be able to choose mechanisms which would not impose blocking or allocation on them still. And it would also be nice, you know, there are already plugins made with the old API. It would be nice if it wasn't too big a change, so that it would be easy to port to the new one. So after a long discussion, we ended up on sort of a fairly simple change. It's actually kind of the splitting up of the processing into one part and the parameter thing into another part, except that the parameter part always takes all of the, in all of the methods, it always takes self by shared reference. And we sort of came to the conclusion that this wasn't so bad, because you needed to do synchronization on the parameters anyway, right? You needed to communicate the parameters between the threads. So you needed to have some kind of thread-safe wrapper around the parameters anyway. So it wasn't too much of a limitation that this interior mutability had to be sort of used for all of the parameter methods. And as you can see here, I've sort of highlighted the new things. So you have the plugin, and then the framework will ask the plugin for its parameter object, and it will return an object in an arc. So a trait object that is encapsulates the parameters for this particular plugin. So the plugin will have its own implementation of the plugin parameters, and it will typically store an arc to that in the plugin, so it can access the parameters and read off the parameters. And then you have, on the other side, you have methods being called on the parameter object. And so we could sort of try and go through the goals and see, are they actually satisfied by this design, or to what extent are they satisfied? So is this safe? Well, we have exclusive references to methods in a few places, like in the plugin still. But if you look closely, you can see that either these methods are either the ones that are like the setup methods, which are only called in this single-threaded case, or they are the processing methods that are only called from the processing threads, and only from one of those at a time. So there will never be multiple of these called at the same time. There can never be multiple methods on the plugin trait called at the same time. This is not the case for the plugin parameters. You can have several called at the same time there, but it doesn't matter because those are all taking the plugin parameters object as a shared reference, so it's safe, right? It tells the Rust compiler these might be called from multiple threads at the same time, so make sure you generate code in a way that takes this into account. In particular, it will enforce that whenever you need to have something that is mutable, you need to go through some kind of thread-safe interior mutability mechanism. And it's also practical for the host, because the host can take these two objects and put them into different threads, and then it can call them from these threads as it will probably want to do, right? And it can have the plugin parameters in both threads, so it can call it from the UI and call it for automation. So the host gets the capabilities that it wants. And we look at some of the other goals, like direct Rust to Rust. Well, there's nothing in this that sort of is the safety of this is not based on the bridging, right? So it can work Rust to Rust. It's just a Rust trait. And for the host, are the rules enforced by the API? Well, some of them are enforced, right? The state switch that, the processing can only be called when it's actually switched into the resumed state. That is not enforced by the API, but that's actually not critical for safety. And it might be something that the plugin still depends on to work properly. But in terms of whether it's safe from a Rust point of view, it is not a problem, right? If the host does it all, follow the rules, then it's all safe. And if it's a Rust host, then it could still call methods in a weird order, but it can still only call one at a time, because it needs to have an exclusive reference to the plugin in order to call methods at all. So that sort of enforces the safety on that side. And in terms of porting this from an old plugin that used the old API, this turned out to be reasonably simple actually, because only the parameters part has changed. All the other part is exactly the same. So everything to do with parameters needed to be sort of extracted into its own object and needed to put in some synchronization mechanism. But you needed to do that anyway to make it safe. So this way we made the API safe, in the sense that no matter what safe Rust you write in your plugin, you will not run into this undefined behavior. There's also, as you can see, some extra markers on the traits. The plugin needs to be sent, because it can sometimes be called from the UI thread. The setup methods could sometimes be called from a thread which is not a processing thread, and then later be called from a processing thread. And it could jump between different processing threads. That happens sometimes. The DAW will have a like a thread pool of processing, because it not wants to do multi-threaded processing, calling multiple plugins at the same time. So it could be called on different threads, but only one at a time. So it needs to be sent so that it can switch between threads. And the plugin parameters needs to be synced, because that is actually shared between threads. So by putting these markers on, this also enforces what you can do inside them. Yeah, and just very briefly, just to touch on, is it actually reasonable to have this kind of synchronization mechanism? I mean, it puts some extra burden on the plugin programmer, right? You have to put in some kind of synchronization between the parameters and the main plugin. And you can do that in multiple ways, right? You can choose to use locking if your plugin is not really particularly real-time critical. You can use locking if you want. It's easy. You can use channels, although it needs to be a kind of channel where the sender can be used from multiple threads at the same time. Not all channels can be used that way. You can use atomics. It's also a simple solution. You write to the atomics in set parameter, and you can read them from the other side. It's a bit tricky to find out there when a parameter has changed and when it hasn't. So the host, the plugin, the main plugin, will often keep like its own copy of the parameters, so it can compare, has it changed since last time. To make this easier, we added to the crate like a specialized data structure where you can say, oh, I have this many parameters, and it can set the parameters, and then it can iterate through the ones that changed since last time. And this is implemented with some bit vectors, so it doesn't have to go through every parameter and compare. Sometimes some plugins can have hundreds of parameters, so doing this like in every processing call can actually be an overhead. But we put in some helper code to make this transition easier. So this was what I had. So any questions? Yeah, Alice.
So you said that the plugin parameters had to be synced.
Yeah.
Do they not also have to be sent?
Probably, yeah. I mean, they are shared already, right? Yeah, I'm not sure. Isn't it usually the case that things have to be sent if they're sync? Or Yeah. So so yeah, if they're already shared between a bunch of threads, then what is the case where it also need to be sent?
If you want to call multiple methods from threads other than the one that was created on the
Okay, yeah, then it definitely needs to be sent. Yeah.
It's because that's encoded in the...
Oh, hang on, no, because it doesn't have any mutable methods.
That's destructor.
What?
That's destructor.
That's just
The destructor.
right. Yeah. The destructor will be called on the thread that where it's created, because this happens in the bridging code usually. I mean, there will be a, it will be, well, it doesn't necessarily have to, right? Because it will usually be shared with an arc, so it could be destroyed on any thread. That's right. Yeah.
I'm just curious. You talked about these VST rules. Are they like? Is there like a specification, or is it just something you observe?
There's kind of a partial specification. There's a specification that tells about the UI thread and the processing thread, and this state change, the resumed, suspended, and what can happen in each. So most of these things are specified in this specification, but there are some details there, right? Like exactly what can be called concurrently, especially things like the set parameter. What are the exact conditions? So it was, I mean, these rules are sort of partially based on the specification, partially on experimentation. So I wrote a plugin that sort of deliberately took a very long time for every method that was called, like several milliseconds every time you call something, and then it would detect whether various methods were called at the same time. So you could actually see what was called at the same time. So I used that to, and then tested that in a bunch of different common doors to see what are they actually doing, right? Because the specification is not always exactly what they're doing. So it's kind of what are the actual practical partially written rules of doors. Yeah.
It sounds like something you probably want as like part of the documentation for this grid.
Yes. So I mean, this is a very old API, right? This is VST2. This was designed long before multi-core processors were common, and they fixed this problem in VST3. VST3 has a complete separation between parameters and processing. It just so happens that VST2 is so common, and is so easy compared to VST3. So there's still a lot of people want to use it.
Yeah, I have one more question. It's just like a totally practical thing. What was the sound program you were using before for the demo?
What was the
program you were using before for the demo? I'm just curious. What was the name of the program where you
Oh, the demo. This program is called Renoise. So it's a music program which is sort of inspired by the old Amiga and trackers and DOS trackers, where you have your notes vertically, the channels beside each other, and then write notes downwards. And it supports all the usual door features like VST plugins and other things. So yeah. Yeah.
Thanks a lot for the talk. I'm trying to understand, like, if when you have a plugin,
Yeah.
I assume that the plugin is making some, or you're making some assumptions about how the plugin behaves in terms of like concurrency and synchronization. Right?
Yeah.
So as a user, when I add a plugin when I'm using Rust to and load the plugin dynamically, I need to essentially prove that plugin enforces those specifications, or I will just assume that. And otherwise, I'm trying to understand, like, how can it be that there is no one safe here? Because there is a dynamic plugin, there is one invariant that the compiler will be unable to prove, which is that the plugin fulfills all the constraints that
Yes.
Rust requires, right?
Right. Yes. So the design of the API, like the safe version of the API, is the idea there is that as long as the host follows the rules and the plugin is only using safe Rust, then you're safe, right? So it's not possible for the plugin to violate or to do something that ends up being unsafe as long as it's only using safe Rust. It can do something like there are some more features in this, like that, something like host callbacks, where the plugin can tell the host things or ask the host for various things. And I think the host could probably be confused if the host callback is called on some other thread than what the host is calling into the plugin. So the plugin could do that, right? And this might confuse the host. So there are some other things there that could go wrong. But in terms of sort of the basic plugin functionality, I think this should be safe this way. But are you thinking about, like, if you are if you're writing a host and then are thinking about whether the plugin is doing something that is safe?
Now I understand. So this is exclusive. I was missing the top. So this is exclusively for writing plugins, right?
Well, it's both, right? So
If you're writing a plugin, then you have, like, the compiler will enforce.
yes,
You're able to prove.
yes.
But then if you're using a plugin, then it's what I was wondering.
If you're using a plugin, it doesn't enforce it fully, right? There are some extra rules you need to follow, especially with the resume, suspend part. And like which threads you can actually call things from and so on. So you have to do a bit more as a host. So the main focus of the redesign was to make sure that you could write safe plugins, given that the host follows the rules. Yeah.
So sound generation logic was written in C++ in this case.
Which one?
Sound generation logic was written in C++.
No,
Wrapped by Rust.
No, the sound generation logic is mostly written in Rust with a very small core in assembly. But I mean, I also have a Rust version of the assembly code. It's a very small piece of code. It's just the assembly code is vectorized and all sorts of things. So, but it's mostly Rust. There's no C++ in there.
So basically, the host is some binary, yeah.
Yeah.
Calls Rust API.
Yes, so the host loads the DLL if it's a Windows and calls this function, and this function is implemented in Rust, in unsafe Rust, which calls into the safe Rust, which is the plugin implementation, which is sort of internally for the actual computation, for the actual adding all the sine waves, calls some assembly code.
I'm curious how you're using this in I'm assuming you're using this for your demo scene projects.
Yeah.
So do you embed a host in your demo scene project, or do you just use it in the editor and then export like a file or something?
Yes, so just use it in the editor and then have a converter which can read the song file from Renoise and convert that to a compact format, which then goes into the demo.
Okay, cool.
And then there's code in the demo that mimics the sound generation that is also in the plugin, so it generates the sound that sounds the same.
How is so you say there's some bridge code that sets it up so that it calls into the right trait implementation. How is that code? Is it like a global static instance of the struct that you've implemented on it, or how does that actually get set up?
Right. So that does have a global that it reads because I mean, it's called. It doesn't really get any kind of context when it is called, right? It just call this particular, do this thing with these parameters, right? So it has a global that it reads. It creates a trade object of the plugin and puts that together with some other things in sort of connected in this global variable, and then it reads that and does the things. And
how's the programming interface like? If I want to develop the plugin,
yeah,
you call a macro to register which information?
yes, you implement the trait and then you just call a macro.
Okay.
Yeah. Yeah. Yeah.
Do you have any thread pool implemented or for faster processing?
So that the thread pooling is the responsibility of the host typically. So when you have a piece of music with many voices that use different instruments, then it will like the same instrument. It has to call on the same thread due to the way the API is. Like they are the same instance of the plugin. So it's all of the notes that are played with that instrument are put in as events to that instance of the plugin. But the different instruments in the music are different instances of the plugin, and those can be called on completely separate threads. They never see each other. So then it's up to the host to have a thread pool to manage all this computation.
You told that plugins themselves can also initialize some threads, utilize some threads. Like, for example, if you want to mix different sounds together within the same plugin.
Yeah, I mean, you could start some threads if you wanted to, but I don't think there's really any point because you would usually assume that the host would do the multi-threading setup. So the individual plugins are just. I mean, the plugin is told to compute the sound for some small piece of sound, right? And then if they're typically in a piece of music, you have many different instruments, and then you have some processing, like a processing chain of plugins after each other, and the host can decide to have some amount of delay where it sort of have as a pipeline of sound going through, so it can do multiple steps in parallel. I mean, the host can do a trade-off between how much it can do in parallel and how the latency is of the sound when you play it. Because the host has the sort of the total overview of what is going on, it's I think it makes most sense for the host to make that decision. Yeah. Okay.